Hello everyone, this is a RoboClock 2.0. My name's Cole.
I'm Rachel.
And my name's Finn.
We designed this for a class for MECH 453 Robotics, and we wanted to make a clock for our project to eliminate boredom in the workspace. So let's start by setting the time on the clock. To do that, all we have to do is press some simple buttons. I'm going to set it to 11, and let's go 58 or 59. We'll see where I get.
In order for the arm to press the hour and minute buttons, their XYZ distances were measured from the base frame. So using those coordinates, we were able to find the joint angles needed for these motions using inverse kinematics. Then the trajectory was generated using trapezoidal velocity interpolation. So in a minute, it'll change from 11:58 to 11:59.
In another minute, it will press the green button, which is the hour button. And to do that, I'm just going to advance it just a minute so we can see what it does.
So if you put your phone in the phone holder, it will also react by doing a nodding movement. And if you take it out, its end effector will shake its head no. And these motions were also created using trajectory generation.
So with this project, there were a couple different challenges. Obviously, with it being a clock, one of the biggest challenges was the 7-segment display. So as we learned through some research, there is a backpack for the specific 7-segment display that we used, and this made the coding a lot easier. There were a couple base codes that we could use to test it to begin with, and a lot of those relied on delay. So one of the biggest challenges was creating a code that was still time dependent without focusing on delay. So we just had to keep track of the milliseconds since the program started, and by doing so we were able to make the arm move at the specific second movement so that it would turn over the minute at the specific minute part.
Some added functionality we added to the design is we added it to be a pen holder. So you can obviously have all your pens and it can sit on top of your desk. It'll keep your phone away from you, as we showed. And we added some fun little interactive buttons. So this button is a multi-function button, and we have it programmed to do a bunch of different things. So that one's hit the green, that one's hit the yellow, that one tells you that you need to focus, and then the next one is stretching, and returning back to the home for clicking clocks. As you can see, this took a lot of wiring and mechanics underneath to make this all work. So I'm going to take out all the pens and show you here. In there we have a lot of resistors, a lot of setup with all the wiring that goes to the Arduino. Our photoresistors, as you can see right here, that's what we have sensing that the phone is there and not. It changed a little bit on the room, but we coded it in so it recognizes what the room's tendency is in order to accurately define the difference. So we had to also step down the voltage, so if the buttons are not pressed, it's always 0, and we got it to work.
Thank you for watching this presentation of our RoboClock.